Today we're talking about writing polynomial equations. So let's talk about irrational and imaginary roots. We learned to find irrational solutions to quadratic equations in Math 2. For example, by the quadratic formula, the solutions of x squared minus 4x minus 1 equals 0 are 2 plus root 5 and 2 minus root 5. Conjugates are number pairs of the form a plus root b and a minus root b. Complex conjugates, a plus bi and a minus bi, where a is a real and bi is imaginary. So remember, complex numbers include all numbers, including imaginary. That's why we call these complex conjugates. So in the irrational root theorem, it just states that if you have a plus root b is a solution, then a minus b root b is also a solution. And if a plus bi is a root of the polynomial, then a minus bi is also a root. So notice that they come in pairs. So you always are going to have the two if you have an irrational or imaginary root. So it says find the remaining zeros of the following functions given the information. So first we have 1 plus root 3, that's an irrational root, so 1 minus root 3 is also a root and also positive root 11. So then looking at the next one, this says degree 6 and the zeros are 2, 2 plus or minus I, 3 minus I, or excuse me, negative 3 minus I, and 0. So in this case, the only additional roots we would have would be for the ones with the i's. So that means 2 minus I is a root and negative 3 plus I. Notice that when you are changing the sign, we don't change the sign of the a coefficient in front. So notice it's just plus bi and minus bi. So you'll notice here that I didn't change the 2 or the negative 3. I just made it minus I and plus I. And then down here, if the zeros are 2 minus I and I, then this becomes 2 plus I and positive I. So next we're going to write the polynomial function in standard form given the zeros. So first we want to rewrite the zeros as factors, multiply, and then put it in standard form. So when I first rewrite these zeros as factor, we know this is x minus 3, x minus 5, and x plus 1. Because remember, when you're writing the zeros as factors, it's always x minus 0. So then the next step would be to FOIL and combine like terms. So let's go ahead. I'm going to FOIL out this first. So we have x minus 3 in front, and then when we start to FOIL, we get x squared plus x minus 5x minus 5, and then becomes x minus 3 times x squared minus 4x minus 5. And hopefully by now you should be able to kind of FOIL it out without having to write all that out, but I'm just writing the steps just in case. And then now we're going to multiply our binomial times trinomial, so then we have to multiply x times all these terms. So that would be x cubed minus 4x squared minus 5x, and then the 3 gets multiplied by all the terms, so minus 3x squared plus 12x, and then plus 15. And now we just need to combine our like terms. So x cubed is the highest power of x, so that's going to go first. There's no like terms with that. Then we have minus 4x squared minus 3x squared, which is minus 7x squared, and then minus 5 and plus 12x becomes plus 7x, and then the constant is the 15. So that would give us our polynomial in standard form. And probably for writing the equation, I'm going to write f of x equals. So down here, same thing for the next one. So this one we have x minus 0, which just, you can write just x. You can write minus 0 if you want, but it's not necessary. And then remember we talked about writing fractions as zeros, or fractions as factors, I should say. So x minus 3 halves is the way that you could write it, but we don't like working with decimals and fractions and multiplying to put it in standard form. So remember, you can get the same 0 by doing 2x minus 3. So we're going to use the 2x minus 3 as our 0, and then we have x minus 2. So here I'm going to FOIL this first out, or you could distribute first, it doesn't matter, I guess. So if I FOIL this out, I would get 2x squared minus 4x minus 3x plus 6. So this becomes 2x squared minus 7x plus 6. And then distribute the x. And again, it doesn't really matter what order you do that in. You could distribute the x first and then FOILed out. So we get f of x is equal to 2x cubed minus 7x squared plus 6x. So that would be our polynomial in standard form. All right. So now let's look at when we have imaginary and also irrational numbers for zeros as well. So it's to note when multiplying conjugates, it gets rid of the square root or the I, and remember that I squared equals -1. So when you're multiplying conjugates, the reason we like multiplying them is because it should get rid of the radical or should get rid of the I term. If it does not, then you know you did something wrong. So if 3 plus 2i is a 0, then you also know by the complex conjugate root theorem that 3 minus 2i is a 0. So we also have 3 minus 2i. So when we're writing the zeros, remember it's always x minus the 0. So this would be x minus 3 plus 2i, and then x minus, and I'm going to do the other conjugate, 3 minus 2i, and then x minus 4. So here, notice that this becomes, then we distribute x minus 3 minus 2i, and this one would become x minus 3 plus 2i. So notice that it's still x minus the 3. The only thing that changed was the minus 2i and the plus 2i times x minus 4. And you always want to multiply your conjugates together first as well. So I'm going to make another note. Always multiply conjugates first. And that's, again, because you should get rid of the square root or the I. So if you want to FOIL this out, you could also make a box if that's helpful. I'm just going to go ahead and FOIL. So if I FOIL this, I have x times x, which is x squared minus 3x, and then plus 2xi, and then the 3, so that'd be minus 3x plus 9, and minus 6i, different color here, and then we have minus 2xi plus 6i and minus 4i squared. So let's go ahead and combine our like terms. So there is no like terms. I don't see with the x squared, because remember this really right here is -1 with the I squared. So that tells me that my first term, and sorry, this is all multiplied by x minus 4. I should write that again because we haven't multiplied that yet. So this gives me x squared. And then we have our x terms minus 3x here. So minus 6x. And then notice I have plus 2xi and minus 2xi. So those cancel out, which should happen. If they didn't cancel out, then we know we did something wrong. And then this minus 6i and plus 6i also cancel out, because remember we shouldn't be left with any imaginary terms. And then so we have plus 9, and then remember if this is minus 4i squared, that's really -4 times -1. So remember that really is plus -4 times -1 would be plus 4. So we have 9 and the 4 that get added together. So that gives us 13. And then we also have to multiply it by that other factor, which is the x minus the 4. So now we have a trinomial times a binomial, and then we're going to FOIL this out again. So that would give us x cubed minus 4x squared minus 6x squared plus 24x plus 13x minus 52. And so then f of x equals x cubed minus 10x squared plus 37x minus 52. All right, so let's look at the next one, question number 4. So this one, it says 4 multiples leave 2 and 5 plus 6i. So if 5 plus 6i is a root, then 5 minus root 6 is also a root. So then for this one, we get 4 is multiples leave 2, so x minus 4 quantity squared, and then x minus the 0, so x minus 5 plus root 6, and x minus 5 minus root 6. So this becomes x minus 4 quantity squared, and x minus 5 minus root 6, and x minus 5 plus root 6. And so I'm going to multiply again the conjugates out first, just to make it easier. So if you like the box method, you can use it. So I'll do the box method on this one since I didn't do it in the last one. So if it helps you to use the box method, so this is a 3 by 3 box because we have a trinomial times a trinomial. So we have x minus 5 minus root 6 and x minus 5 plus root 6. So this would give us x times this, all 3 terms here. So x squared minus 5x, and then minus x root 6, and then minus 5x squared, and then negative 5 to negative 5 is 25. Negative 5 times negative root 6 would be 5 root 6. And then this would be x root 6 minus 5 root 6. And then negative root 6 times positive root 6 would become negative 6. And then you can see right away that your x root 6 and negative x root 6 cancel out. And then also these radicals cancel out. So you look and see that there's not any radicals left in the equation, which should always happen when you're multiplying your conjugates. So when we combine our like terms, and I'm going to write this one out as x minus 4 times x minus 4. So when we multiply and combine like terms, we get x squared minus 5x squared would be our, so sorry, that should have been minus 5x. I don't know why I wrote square, so it's minus 5x. So these are like terms, so minus 10x. And then these are like terms here, so that gives us 25 minus 6, which is plus 19. And then we're going to FOIL this out. So when you FOIL that, it becomes x squared, and you have minus 4x, so minus 8x plus 16. And then x squared minus 10x plus 19. And then we're going to FOIL that all out again. And if you want to make another 3 by 3 box, you can. I'm just going to go ahead and FOIL it by writing it out. So this would be x to the 4th minus 10x cubed plus 19x squared. And then negative 8x times all 3 of the terms would be minus 8x cubed plus 80x squared, and then minus 152x. And give me a second and move this out of the way. And then now we're going to multiply the 16 times all 3 of those terms. So plus 16x squared, and then minus 160x, and then 16 times 19 is 304. And then we're going to combine our like terms. So f of x equals x to the fourth, and then we have this here are like terms, so minus 18x cubed, and then we have the quadratic like terms here, here, and here. There's three of them, so that becomes plus 115x squared, and then we have our linear like terms, minus 312x, and then plus 304. And so that gives us our polynomial standard form. All right, for this next problem, it says, what is the length of the edge of a cube if its volume could be doubled by an increase of 6 centimeters on one edge, 12 centimeters on the second edge, and a decrease of 4 centimeters on the third edge? So remember, we have the side of the cube right now is just x, and the volume is length times width times height. So if it's cubed, it would just be x cubed. So think about your cube here. So there's my cube. So we're saying that what is the length of the edge of a cube? The volume can be doubled by an increase of 6 centimeters on one edge. So this would be x, maybe plus 6 here. An increase of 12 on a second, so x plus 12, and then a decrease of 4 centimeters on the third edge. So let's say the height is x minus 4 now. That's our new length, width, and height. So we have x plus 6 times x plus 12 times x minus 4. So let's go ahead, and that's going to be equal to double the volume. So if the volume is x cubed, that would be 2x cubed. So let's go ahead and FOIL this out. So that gives us x squared, and then 6 and 12 is 18, so plus 18x, and 6 times 12 is 72, so plus 72, and then x minus 4. And so then we FOIL this again, so it's equal to 2x cubed. That would be x cubed minus 4x squared. And then so plus 18x squared. Minus 72x. And then plus 72x minus 288 equals 2x cubed. And so when we combine our like terms, we get x cubed minus or no, plus 14x squared minus, these cancel out, so 288 equals 2x cubed. So we want to figure out what our x value is going to be, so we're going to set this equal to 0 to solve. So we would have, I don't like working with a negative quadratic term, so I'm going to subtract these terms to the other side. Set it equal to 0. So we get 0 equals x cubed minus 14x squared plus 288. And again, you could have subtracted to the other side as well. So we're looking for when our values are 0. So we're looking for the solutions or the x-intercepts to our graph. So if you can't factor this, you can always use your calculator to help. So if we go to our calculator, let's go to our y equals, or turn our calculator on, go to your y equals and plug in your equation. So we have x cubed minus 14x squared, and then plus 288. So if I hit graph right now, let's see, let's assume 6 for a standard window. Right, graph, I see 1, 2, and I don't see the other ones. We know this is polynomial degree 3 with positive leading coefficients, so left end's down, right end's up. So that means I'm missing another 0 to the right. So remember, you could always do factors of p over q to figure out your largest and smallest window. So I'm going to change my window x maximum maybe to 20, and then let's change our y minimum. I'm going to do, since we have plus 288, so I'm going to do negative 300 to 300. Let's go ahead and graph that. Yep, that gives us a much better window as we see our max and mins and our zeros. So here we have a 0 that looks like it's at -4, but of course we can't use a negative answer. So if I do second trace value -4, yep, that would be one of the zeros. But again, we don't want to use a negative answer. So looks like this one's at 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12. So second trace value 6, enter, yep, and second trace value 12, yep. So, and again, you can find your factors by doing factors of 288 over x, and again, if you don't remember your factors, if it helps, you could always do 288 divided by x, and then go to your table. Oops, and then I'm going to put this back on auto. We changed it. So then factors of 288 would be 1 and 288, 2, 144, 396, 472, and then again, you just keep scrolling and you can see all your factors that we have. And then once they start to repeat 16, 18, 18, 16, you can stop. But that's how you can get your factors. We're just doing the rational root theorem here. So then that's, oops, how we got our zeros of -4, 6, and 12. So zeros are x equals -4, 6, and 12. But again, we know that we can't use a negative length. So our length could be when x is equal to 6 or 12 centimeters. All right, the next one says find k such that f of x equals all of this and has a factor of x plus 2. So we know that the factor theorem states that if x plus 2 is a factor, then f of -2 equals 0. So it's one way I can solve this. I can also solve this by using synthetic division. So let's go ahead and use the 0 as a factor. So this would be 0 equals, and I'm going to plug in -2 for x, so -2 to the 4th minus k times -2 cubed plus k times -2 squared plus 1. So then we get 0 equals -2 to the 4th would be 16 plus 2 to the 3rd is 8. So that's negative times negative, so positive, so plus 8k, and then plus 4k plus 1. So 0 equals 17 plus 12k. So -17 equals 12k. So k equals -17 over 12. And again, you could also do this using synthetic division, and then just using your remainder 0 and working backwards. That would also work. And then the last one says, write f of x equals -3x squared plus 30x minus 4 in vertex form. So this is quadratic, so y equals a times x minus h squared plus k. So if we want to write this in vertex form, we want to find the vertex. And remember, we learned in math 2, to find the x coordinate of the vertex, it's -b over 2 times a. So in this case, we have x equals negative 30 over 2 times negative 3, which would give us negative 30 over negative 6, or 5 for the x coordinate. So then if I do f of 5, I get negative 3 times 5 squared plus 30 times 5 minus 4, which gives us then 71. So my vertex form would be y equals your a value. It's going to stay the a value. So remember, our a value here was negative 3. This is the b and this is the c. So we're using that a value. So negative 3 times the vertex now. We just said the vertex is at 5 and 71. So x minus 5 squared plus 71. That would be my vertex form of my quadratic function that was in standard form before. And that is it for the notes for today.